All right, Unit 3, Topic 2, Circular Motion. It's example 23 out of the textbook. Particle moving around a circular radius 3 metres with a constant speed of 2 metres per second, given theta is 0 when t is 0. We've got to find the angular velocity, the position at t equals pi, the velocity when t is pi, and the acceleration when t is pi. This is our rule we need to start with, that for position r outside of cos angular velocity t I plus sine angular velocity t j. First off, we find that angular velocity, and our angular velocity rule is v on r. So that is just simply 2 on 3 radians per second. The 2 comes from the constant speed 2, and the radius is 3. We then go put down our first rule at the top here, and then we substitute it straight in. R is 3, angular velocity is 2/3, angular velocity is 2/3. Whether you write it as 2/3 t or you do 2t on 3, both are correct. So that's our position vector. So if we wanted to then find out r at pi, as it requests, we just need to do 3 cos, and that'll be 2 pi on 3i plus sine 2 pi on 3j. Oops, sorry, I just went a bit awkward on the board. You can find exact values for cos of 2 pi on 3 and sine 2 pi on 3. To find velocity then, we derive, leave the 3 outside the brackets, cos goes to negative sine, and then that 2/3 multiplies out the front. That's I plus sine derives to cos, and that 2/3 multiplies out the front. Now simplifying this up a bit, we've both got 2/3 here and here. We can then factorise that out. 3 times 2/3 is just going to give me 2. So 2 negative sine 2/3 ti plus cos 2/3 tj. And again, if the question asked us to find that at pi, we just substitute it in. T negative sine 2 pi on 3i plus cos 2 pi on 3j. Then to find acceleration, I derive again, leave the 2, leave the negative, sine goes to positive cos, the 2/3 multiplies out the front, cos goes to negative sine, 2/3 multiplies out the front. Simplifying that up, notice both of them inside here have got a negative 2/3, so I take the negative outside, and 2 times 2/3 is 4/3, and then we've got inside. And again, if we wanted to find it at pi particularly, it's going to be negative 4/3 cos 2 pi on 3i plus sine 2 pi on 3j. You can work out those exact values and you've got an exact answer. Done.